Okay, now it's recording. Okay, so here comes to our final lecture notes. Today we are working on the section 7.7, the graphs of tangent, cotangent, cosecant, and secant. In the previous class, we did sine, cosine, those easy stuff. Now, we should do something more difficult, okay? However, all the more difficult stuff comes from easy stuff. Notice that how we define the cosecant x. Cosecant x is defined as 1 over sine x. If we know the values of sine x, we can use it as a reference in creating our cosecant x. Similar with secant x, if we know the value of cosine x, which we definitely know, we can use a reference to create secant x. Before we use our hand to draw it in the traditional way, let's first look at the picture we have for cosecant x and secant x in decimals. Okay, let's share my screen on decimals. Okay, we are looking at the graph. First look on the software, then learned by hand so that we can get a better understanding of it. In the previous class, we did sine x. Sine x are supposed to be one of the fundamental functions in creating other functions, okay? It looks like this. It starts from the origin, then it reaches peak at pi over 2. The peak value or the maximum value is 1. Then it goes down. When it reaches pi, it goes back to 0 again. Then it goes below the negative axis. When it reaches 3 pi over 2, it reaches a minimum value, which is negative 1. And when it reaches 2 pi, it goes back to self. So notice that this function has a period of 2 pi. So that's why it keeps repeating itself every 2 pi, okay? That's the basic properties of sine x. What if we would draw the 1 over it? 1 over sine x. What is that? What is that going on? So you notice that this has a blue line and adjusting to the red line. It looks very weird, very, very weird. Does anyone feel comfortable seeing this photo, seeing this graph? I personally don't feel comfortable seeing such a weird graph. But although it is weird, let's understand it. When sine x starts from 0, 1 over sine x is undefined, okay? 1 over sine x is undefined because sine x is 0 there. When sine x takes a very small value here, 1 sine over sine x takes a very big value. The smaller sine x is, the bigger the 1 over sine x is. It's just the basic property of the fraction. Look how big it is. Extremely high, extremely high. Okay, it's getting extremely high. When you increase the angle. When x gradually increase to pi over 2, sine x reaches maximum when pi over 2, when x equal to pi over 2 at this point, when it is 1. Because in this fraction, the bottom part reaches maximum, which means the whole fraction reaches minimum. The maximum value for the bottom is 1, so 1 over 1 is also 1, which is the minimum value here. Okay? Any questions so far? Okay, so let's continue the angle. When the angle is still increase, sine x decrease. Sine x decrease here. The bottom part is shrinking. So the overall, this fraction, bottom part is shrinking. Overall, this fraction is increasing. That's why you see this blue line is increasing so fast. The sine x is approaching to 0 at pi comma 0 this point. When x is pi, sine x is 0. This blue line can never reach pi because if it reaches pi, the bottom part is 0. Okay, so we don't want a 0 in the bottom of fraction. That will be a huge mistake. So that point is undefined. However, when we are approaching to 0, the bottom part is getting smaller and smaller. So the whole fraction is getting bigger and bigger. Okay, whole fraction is getting bigger and bigger. Okay, so once you pass pi, sine x is still small, but it's already negative, okay? Look at this point. I click a mouse on it. The y value has already been tended to negative, but it's still very small. So let's look how this fraction performs. The bottom part turns out to be negative, but it's still very, very small. So the fraction is also negative. First, it's also negative, but the value is very, very big. Okay, just think about, let me give you an example. Negative 1 over 0.001. So look at this value. The bottom is very small. The whole fraction value is very big, but it's negatively big. Okay. So if you add more 0 here, make it smaller, then it's getting bigger and bigger. If you make it bigger by deleting those zeros, the bottom part is kind of just in terms of value, not in terms of sign. It's getting bigger, and overall the fraction is getting smaller. However, it's still negative. That's why when you take a very small negative value here, 1 over it is extremely big in the negative direction, okay? Any questions so far? Why the function looks like this way? Okay, so quiet, and nobody has any question? Okay, so let's just continue. We were here and we continue our travel. Okay, we'll continue our travel. When x reaches 3 pi over 2, that's when sine x takes the minimum value, which is -1. Okay, when sine x is -1, 1 over -1 is just -1. this cosecant x reaches peak here on the negative part. It's peak here. Okay, and it's also negative 1. So when then you start your journey again, your sine x increase, but still negative. 1 over that small negative value is getting bigger and bigger in terms of the negative direction, in the negative direction. Okay. In this, we'll finish one period of the sine x and how the cosecant x behaves according to it. Okay, so any question before we work on the lecture notes to write them by hand? Right now, I'm just giving you an idea how things will look like on our lecture notes. Okay, so let's continue to our lecture notes. Okay. First, we need to draw the graph of y1 equal to cosecant x 1 over sine x. Before we draw that graph, we need to draw just sine x itself so that it can work as a reference for our future drawing. So you everybody know that the sine x looks like this. Okay, this is just a rough sketch. This is how a sine x looks like. Okay. Again, we need to draw a few key points in order to get the cosecant x. Okay. So when x is 0, what is 1 over sine x? When x is 0, sine x, let me write this. Sine x cosecant x. When x is 0, sine x is 0. Cosecant x, which is 1 over sine x, is 1 over 0. It is undefined. Okay. In other words, you can think about 1 over 0 is something extremely big. It's not a real value anymore. It's something extremely big. Or you can think about it as infinity, if you know this sign represents infinity. How about when x is pi over 4? How about sine x?
Pi over 4?
Yeah, when x is pi over 4, at this point, pi over 4, how about sine x? Can anyone tell me a value of it?
The square root of 2 over 2.
Thank you, great. Okay, square root of 2 over 2, which is approximately here. And 1 over that is 2 over square root of 2 over 2, right? 1 over this value, which is just square root of 2. And some of you may know square root of 2 is 1.4-ish. So if this is 1, This is 1.5, 1.4-ish is somewhere here. Okay, somewhere here. What if x is pi over 2? Can anyone tell me a value of sine x? It is 1, right?
Yeah, 1.
Yeah, great, thank you. 1 over 1 is 1, so it gets to this value. What if we get x equal to 3 pi over 4?
When we get the same pi, square root of 2 over 2?
Very good. You go back to square root of 2 over 2. Then cosecant is square root of 2. So you go back to this point, a little bit below 1.5. Okay, my graph does not look so nice. What if you get to 2 pi? Sine pi is 0. 1 over 0 is still undefined. Also, you can write pi. Oh no, I'll write infinity. Let's continue our journey to the negative side. When you go below pi, when you reach this point, should be 5 pi over 4. You reach this value, 5 pi over 4. What's sine pi, 5 pi over 4?
Negative root 2 over 2.
Very good. It's just turned out to be negative. Everything is still the same, but it just turned out to be negative. And the 1 over it is just negative square root of 2. Okay, 1 over this value is just negative square root of 2, which is here. Similarly, when x goes to 3 pi over 2, sine pi turns out to negative 1. 1 over negative 1 is negative 1. And when x goes to 2 pi, eventually 2 pi here. Oh, not 2 pi yet. We did 3 pi over 2 already. So the next one is 7 pi over 4. 7 pi over 4, which is this point. 7 pi over 4. This is 5 pi over 4. Again, you reach this value, the same with 5 pi over 4, square root of 2 over 2. Then it goes back to negative square root of 2. Then eventually we reach our last point, which is here. Two pi sine x 0, 1 over sine x or cosecant x is undefined. Or you can write infinity. So let's find the value on this guy. Here, you are looking for a negative square root of 2. So this is negative 1/2. Negative square root of 2 is somewhere, approximately somewhere here. I apologize. I should not write 5 pi over 4 here. I should write it there. It makes things look ugly here. Then here, the reach is negative 1, as it did. Then here, it still goes back to negative square root of 2. Then here it goes to infinity. The pi it also goes to negative infinity. Okay, negative infinity. Let's use an arrow to represent negative infinity. So let's connecting those curve points. Goes to negative infinity. This side is going to positive infinity. So if you're connecting those points, you'll get something look like this. Okay. This is cosecant x. This line is sine x. We all know it already. Okay. Any questions so far? Okay, so what did you notice? What did you notice?
Should the points always be connected?
Oh yeah, that's a great point. Connect dots. Okay, eventually. Okay, what else do you notice? Notice?
There's a negative and a positive parabola.
I'm sorry, can you speak louder? I cannot hear you clearly.
There's a negative and positive parabola.
Very good, very good. So notice that when we are the sine x is approaching to 0 somewhere here, we have undefined points or infinity points. Okay, there can be issues. So the second thing we notice that when sine x equal to 0, cosecant x is undefined, or you can write infinity. So let's break this statement into details. So when would sine x equal to 0? Anyone has any idea when sine x equal to 0? Just look at the graph.
Isn't it at 0 and then again at 2 pi?
Yeah, and also pi, right?
Oh yeah, and pi, yeah.
So to say it in a more generalized way, that if you draw the graph on this side also, you will notice that when x equal to k pi, k is the integer. When x equal to k pi, k is the integer, sine x equal to 0. Okay, so when k is 0, x is 0 pi, which is here. This is 1 pi, this is 2 pi, this is negative 1 pi, this is negative 2 pi. They all take those negative values, take 0 values there, sine x. Okay, if I draw the graph, you'll see it all cross 0 there. Okay. To break this little bit to further details, 0 plus minus pi plus minus 2 pi plus minus 3 pi, da da da. Okay, that's what I mean by saying k pi. K is the integer. That's it. Any questions so far about this function, about this graph? Sorry, this is kind of messy. I should write this table on this side. Okay, so that we do not need to overlap some of it. Just to be clear, let me draw a divide line here. Okay. Okay, let's continue to the next page. Okay, we are done with y equal to cosecant x already. This time we should further consider something more difficult. We consider the extension of it. This time with 2 times of it. And we also multiply 3 to the x. as we explained last time, if you multiply a number to the x, you are actually shrinking the graph. Okay, shrinking the graph. Look at my hand, shrinking. So if you multiply 2 of it, everything just get 2 times the value, 2 times the value, 2 times the value. Okay, just think about my hand, how my hand grows. In this case, A is 2. So, and we told that cosecant x, okay. Cosecant x, which do not have a maximum value. This kind of looks like something like this, okay? Let's see the previous graph. It looks like something like this, goes extremely big when x is approaching 0 or pi. So the amplitude, because it turns out to be extremely big, the amplitude does not exist. Do not exist. Okay? We define the amplitude to how big it can oscillate, right? How big it can oscillate when we were learning the sine function. However, this time, because it can go extremely big, so it would just claim it do not exist. How about the period? We have a 3 here. And as I just told you that, when you have 3 times x, everything shrinks to a third of it. Everything shrinks to a third of it, shrinks. So originally, sine x period is 2 pi, okay. So if everything shrinked a third of it, so now the new period is 2 pi over 3. That's it. Any questions so far? Huh. Okay, so let's continue. Okay, originally you have 2 pi over 2 here, but everything shrinks here. Okay, so originally if this point is pi over 2, now this point is pi over 6, just 1/3 of pi over 2. Okay, so we're just changing the coordinates so that our graph would still fit into the coordinates. Okay. What's the maximum value sine x takes? Original sine x takes 1, but now you're 2 times the maximum value. Instead of taking 1, what does it take? It takes 2.
It would take 2, yeah, 2.
Thank you, very good. It takes 2. Okay, so this point turns out to be pi over 3. So if we just draw the sign will look like this. However, we're not drawing the sign. And we know the cosecant function looks like this. Okay, it just looks like this. It's similar with a parabola, but it's more extreme than a parabola. Okay. So it still goes to this point, the cosecant, this new cosecant function goes to this point, and it still goes to infinity in this direction. Okay. So let's draw a rough sketch. This is a very rough sketch of it. Just bear with me, bear with this art class. Okay, this is the positive side of it. It's a very rough sketch. sketch. And once you go below this pi over 3, now you should have a point here. Okay, because this takes -2 here. And you should also sketch another going to -infinity. Here. Okay. So that's our rough sketch. I think that's good enough. Okay. Then our question is domain. Domain, let me write what domain is. Domain is, well, the function can take a value. Okay. So when can this function take a value? Let's go back to the previous page. When it can take a value, first of all, those points are where it cannot take a value at k pi. 0 pi plus or minus 2 pi plus or minus 3 pi. Those points are where it cannot take values. So all other points are fine. Okay, all other points are fine. Just don't take those bad values. But when we are talking about sin x, we use this k pi. This time, we're talking about 3x. So 3x cannot be k pi, okay? Notice that you cannot take this value, pi over 3 or 0. In other words, x cannot be k pi over 3. It cannot take those values. This k equal to 0, 1, plus or minus 1, plus or minus 2, dot, dot, dot. So it cannot take this value. It cannot take pi over 3. Look, it's going to infinity there. It cannot take 3 pi over 2 or 2 pi over 3. Okay. So the domain is just where all points except k equal to k pi over 3. Except x does not equal to k pi over 3. K equal to 1 plus or minus 1 plus minus 2, blah, blah, blah. Okay. Any questions so far?
Does that say that k is equal to 0?
Yes. K equal to 0 plus minus 1 plus minus 2, just like what I written down here.
Okay, perfect. Thank you.
Thank you for asking. Okay. Except those values, all points are okay. How about the range? You start from 2, you can go infinity high. You start from -2, you can go infinity low. So range is -infinity to -2, bracket, so that this point is included, okay? Because you can take values here at -2. So this point is included. That's why you use bracket, not parentheses. Then union +2 to +infinity. Okay. Any question about the range? How we get this such a notation? Okay. So let's just continue. We actually did those steps already, okay? We just follow the steps. We did those steps already. So let's draw a new graph about secant x. Secant x, how secant x is defined? Secant x is one over cosine x, right? So how about secant 2 pi x? It is 1 over cosine 2 pi x. Okay. Then you need to times -1/2 of it. We need to draw the picture of it. Before we do that, let's first look how it looks like on the Desmos. Okay, let me share my screen about Desmos. Let me share my screen. Desmos. Okay, so now you are on my Desmos again. So let's first look at how cosine x look like. Cosine x looks like this. Okay, so when x is 0, it reaches maximum value, then it decreases until it reaches pi over 2. Then it gets 0 here, then it decreases. Then x is pi, as cosine pi is -1. Then it reaches, when it goes to 3 pi over 2, cosine x goes to 0. Then when x goes to 2 pi, because we are following a 2 pi period, the same value as x is 0. So that's why the text 1 there. Okay, it goes back to 1. So it's repeating itself in this way. How about 1 over cosine x? Very similar with our previous graph. Every time cosine x takes high values, 1 over cosine x takes lower values. Every time cosine x takes smaller values, 1 over cosine x takes big values, even some extremely big values until it goes to 0, which is undefined. For this point, cosine x is undefined. And when it goes to negative, it can be extremely negative. Okay, in these directions. Okay, so when it touches -1, you see 1 over cosine x is also -1. They reach the same point here. So any questions so far? Okay, so let's shrink the cosine values by 2 pi, so that we get 2 pi x. This looks so ugly. So let's just keep the original cosine, 1 over cosine x. Okay, what do you notice? Originally, you have a black curve repeated regularly. Now, when you times 2 pi of it, the period shrinks. So you see more and more red values. Okay, more and more red values. It appears much more frequently than the black curves. Okay, so let's look at what if we have 2 times of it? How does it look like? Instead of 2 times of it. Okay, so now you see a new. Let me get rid of black curve. Just keep the red values. You see, originally your minimum value is 1. Now you are 2 times of it. You take 2. Every value just doubles. Every value just doubles in this way. Okay, originally you take -1 here. Now, the -1 turns out to be -2 since there are 2 times that value. So when you are negative, you can go even further negative. Just look at the graph. Even further, you can go even further. So make a number 2 times that value, make positive numbers bigger and make negative numbers lower, okay? Okay, any questions so far about the graph? Okay, so let's go back to the next notes. Again, since we can go extremely high, extremely low, amplitude do not exist. Period. Originally, you have a period which is the same with cosine x, which is 2 pi. Now you are 2 times that x. So everything shrinks by 1 over 2 pi. Everything divided by 2 pi. Original period is 2 pi. Now you have 2 times x. 2 pi times. You gives you period which is 1. Okay. Good. Then our last step is shrink a preliminary graph about it. Oh, before we do that, we should also talk about the domain and range. Okay, so look at the second x. What is it? Where can this function go wrong as a fraction? That's where the bottom part turns out to be 0, right? That's where the point can be wrong. When can cosine x become 0? Let's look at decimals. When can't be 0? Cancel it. Keep cosine x. So now you see when cosine x becomes 0. Note that when x is pi over 2, it turns out to be 0 here. When x is traveling, When it reaches here, it turns out to be 0 again. When x is negative pi over 2, it was 0. And at this point, it also becomes 0. Do you guys see a pattern here? Just a pattern. It goes to 0 every pi, starting from this one, right? If you add a pi to this x coordinate, negative pi over 2, it goes to 0. Then if you add a pi to this value again, it goes to 3 pi over 2, which is also 0. If you add another pi, it goes to 0 again. So what can we say about that? So let me switch to my document camera. So cosine x equal to 0 for x equal to pi over 2 plus k pi. Okay, so it repeats to 0 every pi. Here, k is just an integer. By saying integer, I mean any number like 0, pi, or 0, 1, 2, that kind of integer. So that's where the bottom part takes 0, and we want to avoid those points. So x cannot be pi over 2 plus k pi. In other words, this part 2 pi x cannot be pi over 2 plus k pi. So x cannot be divide both sides by 2 pi. You got 1/4 plus k over 2. Okay, all the pi canceled out. You're just dividing both sides with 2. So this k turns out to be k over 2. K is an integer. Okay. Okay, so now we know, sorry, this is not equal sign. Domain is where x cannot be k equal to 0, comma, plus or minus 1, plus or minus 2, dot, dot, dot. Okay. So how about the range? We are times negative 1/2 of it. So which means originally this function looks like somewhat like this, go up and down. Now we are times negative 1/2 of it. So let's look at the effect on the decimals. Negative 1/2 of it. Look. Okay, let's first do 1/2 of it, then add the negative sign. Okay. Originally, the graph looks like this purple line. If you times 1/2 of it, everything just goes down, right? Goes down by 1/2. When it was negative, you times 1/2 of it, everything just increase. Okay, just increase. Since it was negative, you times 1/2 of it, it cuts the negativity by 1/2. What if we add a -1 to front of it? Negative sign. Be ready. We are flipping the graph. Look, originally the black line is somewhere here. Since your time is -1, it flip to the other side. Okay, flipping to the other side. Okay, so original takes 1 here, but now it takes -0.5 here, which is turn out be negative the half of the art. Okay, that's the maximum value on the negative side. And the minimum value on the positive side is 0.05. Okay, so now we know the domain. Let me switch to my document camera. So now the domains -infinity to -1/2, union +1/2 to +infinity. Okay, any questions so far about the domain? It goes to from +1/2 to infinity above, and -1/2 to infinity lower. Okay, now we should sketch the graph. Let's see. Let's see how the graph looks like. Okay, this is how the graph looks like. Cosine 2 pi. Looks very, very weird. First, we found out this point. This point is -0.5. Okay, let's mark it. This is -0.5, +0.5. Then it takes value at 0.5, then it goes infinity high on these sides. This is 1. This is 1.5, 2. So it would like this. Okay. Okay, so we roughly sketch the graph already. Any questions so far? Okay. Given that there is nobody asking any question, let's just continue. This time we need to draw the graphs of tangent x. Tangent x. Again, we need to know where it is undefined. So in order to figure out where are the bad points, or we often say it's undefined, we need to understand the structure of tangent x. What is tangent x? If you have a unit circle, it give you an angle. Tangent x is this side divided by this side, right? This side divided by this side. However, if you gradually increase this angle, this side can be 0 somewhere. The x coordinate can be 0. For example, if you increase your angle to here, the x coordinate for this point is 0, okay? The y coordinate divided by x coordinate. Similarly, if you make it to this point, the y coordinate divided by x coordinate is also 0. Okay, those are the bad points for it. Let me write it down more clear. Tangent x is a y coordinate divided by x coordinate. So whenever the bottom is 0, we have some bad points. So let's look at y equal to tangent x. Let's do a few values. First, when x is 0, tangent x is an angle, okay? X is an angle, or our input. Tangent x is tangent 0, which is this point, the y coordinate, divided by this point's x coordinate, give you 0. Then when x increases from 0 to pi over 4, how about y? You get to this angle. For this point, it has the same x and y coordinates, right? Because this side equal to this side. So you get tangent pi over 4 is 1. And again, when you increase, notice that when you increase the x, increase this angle. Okay, notice that this x is representing the angle and does not represent the same thing as the x coordinate. They're not, they're different. It just happens that we write them in the same way. Again, go back to the angle. When the angle increases, we teleport into pi over 2. The x coordinate is getting smaller and smaller. Just think about the x coordinate of this point, getting smaller and smaller. How about the y coordinate? Y coordinate is approaching to 1. So the fraction is, the upper part of fraction is 1, the bottom part is approaching to 0. Okay, you get something undefined. Or when you're approaching to it, you are approaching to positive infinity. Again, we write undefined or positive infinity. Okay. Any questions so far? Okay, so once we pass over it, on this side, we still have a positive y coordinate. However, our x coordinate turns out to be negative. Okay. On this side, our x coordinate turns out to be negative. So now you have -1. And when you get to pi, you complete this half circle, you get to pi. Your x coordinate is -1. Your x coordinate is -1. Your y coordinate is 0. So 0 over -1. So you got 0 again. Okay. So in this way, you finish a circle, then finish a half circle, or we can say it a period. So let's look at how it behaves on the decimals. Sine x over cosine x. Okay. We just mentioned that when x is 0, tangent x becomes 0. So when x is 1, or when x is pi over 4, where did we get pi over 4? This point, you get your 1 value. Okay, then you moving your angle again. You see it's getting infinity high, extremely high. This was because the x coordinate is approaching to 0, y coordinate is approaching 1. The bottom of the fraction is so small. The bottom of fraction, which is here, so small. So overall fraction value is getting so high, extremely high. Okay. Then eventually you are reaching the value of 1 over 0, which is undefined. That's the infinite point. Okay. But once you pass over that point, just like what we did in the unit circle, it goes to negative, extremely low, negative. Then the increase, no matter how it increase, is still on the negative side. Then you repeat this circle, you gradually increase and get to 0, and then you get to infinity. Okay, so any question before we draw it on the paper? I know things look very weird at the first time. So when this class is over, please review our lecture notes. Please try to draw the functional decimals by yourself, okay? So right now, let's go to the paper to draw the rough picture of it. When x is 0, and 0 here. When x is pi, it gets to 1 here. When x goes to pi over 2, it's going to infinity high. So the graph looks like this on this side. We can also do it on the, once we pass this point, 3 pi over 4, which gives you -1, which is here. Then it goes to pi, goes to 0 again. Again, you are coming from negative infinity on this side. Negative infinity. Use the arrow. Okay. So if you extend on this side also, you will see a similar pattern. We don't have enough time to cover all the details here. If you extend it to this side, similar pattern. Okay, just like what we saw on the decimals. Okay, so based on what we see on the decimals, and now what we draw here, how often does tangent x repeat itself?
Isn't it just every pi?
Very good. Very good. Every pi. Notice that when we get to 0, it is 0. When we get to pi, it's 0 again. So I didn't draw this 2 pi. So if we get to this 2 pi, it repeats itself again. So every pi it repeats itself. Every pi is repeats itself. Period is pi. Okay, pi. Now we're doing cotangent x, where to be undefined. Cotangent x is cosine x over sine x. In other words, every time sine x takes 0, cotangent x is undefined, right? Because this is just fraction. So when does sine x take 0? Sine x equal to 0 for x equal to k pi. So x equal to k pi, that's where cotangent x is undefined. Okay? I'm just using this as a result. So we talked about this before. So if you are unfamiliar with it, please review your previous lecture notes, or you can see it on Desmos. Okay. I think I can just spend 20 seconds showing on Desmos where it goes to 0. Okay. So just to show the detail. So when x is 0, it goes to 0. When x is pi, it goes to 0. When x is 2 pi, it goes to 0. When x is 3 pi, it goes to 0. When x is negative pi, it goes to 0. This is a sine x, okay? That's why I'm saying that it goes to 0 every time. Okay? So those values are bad points for cotangent x. Oh, we reached the end of the class. How time flies. Okay, so let me take the attendance. Do not go before I take the attendance. Give me 20 seconds. I need to take the attendance.
And then Professor, I had a question.
Yes, please.
So on Thursday, we're gonna have a quiz on the stuff we did last week, right?
Very good. So you can look at the syllabus to know what we did on last week.
Okay.
Okay, I finished the attendance taking. Stay here if you have any question. Otherwise, feel free to go. Bye-bye.
Have a nice day.
Thank you.
Nice day.
Thank you.
Thank you.
Thank you.
I just have a question.
Yes.
So with quiz 2, I wasn't able to upload it as a PDF, so you said I could email it to you.
Yes. Did you do that already?
Yeah, I emailed it to you that day, but on Canvas, it's on there as a 0 out of 20. I did figure out how to upload it with quiz 1. So would you like me to go back in there and upload it?
So, okay, you have two questions. First, about quiz 2, you didn't, you emailed it to me already, right?
Yeah, on last week, Thursday.
Okay, let me search my email to make sure I received it. Otherwise, your name is Sharon, right?
Yes.
Okay, I did receive it.
Okay, would you still, I figured out how to upload it as a PDF. Would you still like me to do that? Or is that okay?
Yes, please. Yes, please. You need to learn how to do that. Since all our exams or quizzes are uploaded in this way, you better to know how to do that.
I'll go ahead and upload it, and then will it be considered late since it was emailed to you?
I forgive this lateness for the first time
Okay.
because at the beginning of class, I understand many of you may have difficulty just for technical stuff.
Yeah.
So I would forgive for the first time. So next time, please learn how to do it.
Okay. Yeah, I was able to do it for quiz 1, so I'll go ahead and upload it.
Okay, Thank
Right.
you.
Yeah.
Goodbye. Hello. Does any of you have any question?
Yeah, I just had a quick question. I think we did a recording last Thursday of class, but I haven't seen it posted. I just wanted to go over my notes. Is there any way you could post a recording for last Thursday?
What? I forget to post a real recording. Let me see.
At least when I last checked, which is a little while ago.
Look, it's here.
It's not posted for us though, I don't think.
It's not posted for you? Oh, yeah.
Yeah,
Okay, great. Thank you.
no problem. And
Thank you
then,
for
oh, sorry.
posting it right now. I just click on it.
And then I had one more question. So we do My Math Lab every single week. Are you gonna put the grades from My Math Lab into Canvas?
Yes, thank you for reminding me that.
No problem.
Yeah. If you don't remind me, I'll forget about it and maybe do it at the end of the semester.
Okay,
Yeah, thank you for reminding me that.
no problem. Thank you so much. Have a great day.
Okay, you too. Goodbye. Hi, so Lucia,
Hi.
is
So
there anything I
I
can
have
help you?
two things that were concerning me basically. So the first one is I tried downloading what you told me, the Adobe thing.
Adobe Scan, but yes.
Yes. My laptop won't let me because there's no space on it. So last night,
So you do it on your cell phone. Adobe Scan is on your cell phone.
oh, I thought it was on my laptop.
Yes, I sent you on the email. You can watch that video, how to download and install it on a cell phone and how to use it on a cell phone. It's all on the cell phone.
Oh, okay. All right. So
Okay.
then, yes, last night that I was trying to do it again, how you know how like for the first time I also struggled. So last night I was struggling to do it, to upload it and scan it, because I thought it was through my laptop that I basically it shows that I turned it in like 15 minutes late, but it was because I couldn't figure out how to like transport it from a PDF or to a PDF and then get it on my laptop.
Okay, so once you use Adobe Scan, everything will be super easy. You can easily scan it as PDF and upload it to your computer. So all you need to do is watch that video. That video has all the information to tell me how to do that.
Okay. I was looking for it on my laptop, and then my laptop kept telling me that there wasn't any space to download anything. Will it still be considered late?
I will forgive you the lateness for the first time since everybody has having some kind of technical difficulty at the beginning of the semester. So please do not worry about it. I will accept it.
Okay, sounds good. Well, I think that was basically the only thing that was concerning me.
Okay, cool. So if I didn't upgrade your grade, so just drop me another email. And you know I'm very
Okay.
busy, and I'm
Yeah,
also very forgetful. Busy
no
and
worries.
forgetful. So if I forget
Yeah.
something, feel free to drop me as many emails as you want.
Perfect. And that one was for, what was it? For quiz one that I couldn't last night.
Okay, cool.
Okay. Thank you. You have a good day. See you
Okay,
Wednesday.
goodbye.
Bye.